Today in Math 20-1 we're going to look at solving systems of equations. And in topic 8.1 we're going to look at solving these systems of equations graphically. To solve a system of equations means to find a value for x and for y, or called a point xy, that fits both graphs. This is the point where the two graphs will intersect, and that's called the solution to the system. If we look at several diagrams, in the first diagram we have two linear equations. They're going to meet in one spot. That's going to be one intersection point, and that's going to be considered one solution. In the second graph we have a linear quadratic system. There is no intersection point. That means there's no solution to this system of equations. Thirdly, I have also a linear quadratic graph. This time there's two intersection points because the graphs cross in two different points, and that means that there's going to be two solutions to our system of equations. In these last two, here we have, again, a quadratic system. This time there's no points of intersection, so there's no solution. These two graphs, they're going to touch in just one spot. That means that there's going to be a quadratic system with one solution. And here we have a quadratic system where they're going to cross twice, and there's going to be two solutions. Here we have example 1. Using your graphing calculators or pencil and paper, find the solution to the system of equations. Y equals 2x plus 3 and y equals negative 3x plus 8. Well, you can generate a set of ordered pairs for both these graphs. If x is negative 2, 2 times negative 2 is negative 4, plus 3 is negative 1. All down the list, doing the same for both. And if you graph these two systems by plotting some points, you're going to see that they're going to intersect in one spot, and right from the graph you can read that that's going to be where x is equal to 1 and y is equal to 5. Or you can look on your table of values for each, and you can notice that 1, 5 is the same ordered pair for both. Where there's one intersection point, there's going to be one solution. In example 2, we're going to solve this one using our graphing calculator. We're given 4x minus y plus 3 is equal to 0, and 2x squared plus 8x minus y plus 3 is equal to 0. Well, I noticed the first one's a line, the second one is a quadratic equation. So this is going to be called a quadratic linear system. If we solve for y in both of these equations, you're going to get y is equal to 4x plus 3 and y is equal to 2x squared plus 8x plus 3. We can set y1 to equal our first equation, y2 to equal our second equation, enter those in our calculators, and use second, trace 5, and then enter, and this will give you one of your intersection points. To find the second intersection point, you're going to press second, trace 5, and then you're going to use either the left arrow or the right arrow to move your cursor close to where the second intersection point is. And at that point, you can press enter, and it will give you your second point. Now, our two solutions for this system are going to be at 0, 3 and negative 2, negative 5. In example 3, we're asked to solve 2x squared minus 16x minus y equals negative 35, and 2x squared minus 8x minus y is equal to negative 11. Again, if you rearrange these two equations, you're going to get y is equal to 2x squared minus 16x plus 35, and y is equal to 2x squared minus 8x plus 11. Again, plug them in your calculator. You're going to find that you're going to have an intersection point, only one intersection point, and that's going to be at 3, 5. Now you can verify that. You can plug in 3 for x, 5 for y into your equation, and you should get negative 35 equals negative 35. And in the second equation, you should get negative 11 equals negative 11. That's how you verify that you've got the correct solution. Okay, in our last example today, it says to apply a system of linear quadratic equations. Engineers use vertical curves to improve the comfort and safety of roadways. Vertical curves are parabolic in shape and can be used for transitions from one straight grade to another. Each grade line is tangent to the curve. There are several mountain curves on the Trans-Canada Highway through the Rocky Mountains. To construct a vertical curve, surveyors lay out a grid system and mark the location for the beginning and the end of the curve. Suppose surveyors model the first grade line for a section of road with a linear equation of y equals negative 0.06x plus 2.6. The second grade line, the one that goes up, is going to be the linear equation y equals 0.09x plus 2.35. And then the parabolic curve that's going to bring those two together is going to be the quadratic equation y is equal to 0.0045x squared plus 2.8. All right. Now, what we're going to do is write the two systems of equations to be used, because we're going to find two different points. We're going to say y is equal to negative 0.06 plus 2.6 and 0.0045x squared plus 2.8, and the third curve is y is equal to 0.09x plus 2.35. Now you can do these two separately, or you can graph all three functions together and find their intersection points. And what you're going to do is you're going to get a picture, if you set your windows properly, that looks something like what we have in the top right hand corner. We have a point of tangency, and that is going to be where the line will meet the curve. So we have to find two intersection points. So the graphs are tangent at negative 6.67 and 3, and at 10 and 3.25. Therefore, the vertical curve is going to start at negative 6.673, and it's going to end at location 10 and 3.25. So, for your assignment, do page 435, numbers 3 to 9.